Yellow. Welcome, everyone. Thank you for checking in today. This is page 311, and we are continuing activity 4, where we're talking about parallel line converse theorems. Converse is what you do, well, besides the shoe, right? Converse is what you get when you take a statement in mathematics, one that's written with if-then, and you switch the if-thens in their order. So what was the if-then of our structure becomes the then statement and vice versa, kind of a switching around. Well, if you have your same side interior angles theorem card, we're going to talk about the converse. And by talking about converse, we really mean we're going to take what was the if statement. If a transversal intersects two parallel lines, and the conclusion, so yellow is hypothesis and pink is conclusion, then the interior angles on the same side of the transversal are supplementary. We're going to switch that around. We're going to make pink go first and yellow go second, because that's the converse. So having my note card here on the side, a little copy paste as we go along. If the interior angles on the same side of the transversal are supplementary, write all that down. Okay, so we take that if statement, or the then, I should say. We take the then statement of how it was when we copied it down from page 306. And in fact, I've ripped out page 306 carefully because it's going to be part of the next activity here. You take the if part of it and you write it first. You take the then, so then the transversal intersects parallel lines. That's the proof of what we're doing this. We're trying to show that, you know what, those lines that we created must be parallel. So then the transversal, there's a little switch around in the wordplay. You don't want it to be too robotic. So maybe like an A becomes a the, but there's a lot of the key details that are there. Then the transversal intersects two parallel lines. So in all honesty, this theorem is actually biconditional. It can if then in both directions and give us some very valuable information. We're going to actually prove this, though, and in order to prove it, like I said, I recommend that you actually have page 306. We did the activity where we cut out the cards and sorted them, because if you work through, let me move my face out of the way, if you work through a proof, actually you're working in a reverse path up to the given. It's like what was the given is now written down here at the end. And so that's what we're going to do in this proof, is we're going to start with some given statements. In essence, we're going to start with the fact that we have a given angle and angle. Oh, and we're also using the diagram. So look at the diagram on page 310. We're going to use this diagram in order to start things off. To start things off, we better identify same side interior angles. That's our if statement. This also guides us to choosing our first, find the card, given, our first given, and we're using given in another time. So tally of the number of times we need to use given. It seems to be increasing. Have that card ready to go. Okay, given. I'm going to focus on angle 1 and angle 3. And I'm going to focus on angle 3 and angle 5. All right, so we'll say, first of all, again, trying to use this, but in reverse. All right, so angle 1 and angle 3. No, I'm saying the wrong words already. Oh, my goodness. Scratch, scratch, scratch. That's okay. We'll fix it. Get on track. Given angle 3 and angle 5 are supplementary. That is given. And also given, right? Bring me back in. Also given, just because it's there in the picture, angle 1 and angle 3 form a linear pair. So I want to make sure that I bring in my other linear pair, right? Angle 1 and angle 3, they're kind of turned like this. They form a linear pair. This is also given by the picture, given by the diagram. Those two statements are going to produce some information. So first of all, if things form a linear pair, then that means that they are supplementary, which means that they add to 180. So I'm just going to jump through a couple of hoops, right like this. The measure of angle 1 plus the measure of angle 3 equal 180 degrees. And the reason here is because linear pairs are supplementary. So like I guess I'm kind of blending a couple of things, like linear pair means supplementary. Okay, so if I go up here to angle 3 and angle 5 are supplementary, that means I can write a statement. I can say this. I can say angle, the measure of angle 3 plus the measure of angle 5 equals 180 degrees. Put a box around it. There's my statement. My reason is that supplementary means they're equaling. They add up to 180. Definition of supplementary. Let me see, how far on course am I still with what we did on the previous page? We have definition of supplementary angles. Oh, we're going to use the substitution property. That's right. Okay, so substitution property says that if both of these are equal to the same thing, then the measure of angle 3 plus the measure of angle 5, which equals 180, and the measure of angle 1 plus the measure of angle 3, that also equals 180, so they must equal each other. But wait a minute. They both have a 3 in common. They both have this angle 3 in common. And by the congruent supplement theorem, angle 1 and angle 5 are congruent to each other. So I can just jump through quite a few steps here. I can say angle 1 is congruent to angle 5. Put a box around it. And that's bringing this statement together and then this statement together. And I have to bring in my reason, congruent supplement theorem. Congruent supplement. This is where the shortcut comes in, right? We've already proven, or you should go back and watch that video, that if two angles are supplements of the same or congruent angle, then the angles are congruent, meaning angle 1 and angle 3 are congruent because they are supplementary to an angle that's the same size, like 2 and 4. So they must also be equal. But there's a whole lot of process that goes in there. Now, if you have angle 1 and angle 5 being congruent, we also know this. Angle 1 and angle 5 are corresponding. Right? Look at the diagram. Slide it back over. See right here? Angle 1 and angle 5, they both open the same way. And because they do, which shouldn't really surprise us, look, that was on page 306, angle 1 and angle 5. So since they are congruent and they are corresponding angles, then that means that W, line W, is parallel to line X. And the reason is that corresponding angles are congruent. So it's the corresponding angles converse. Right? That was also from page 304. You guys, this is the entire flow proof. I'll zoom out for you by lifting the camera out of the way. This is the entire flow proof for this page. Notice that it has some givens. We do something with those givens. I have a statement that will end up becoming the boxes, the next box's reason. I have a statement that will become the next box's reason. And so with that sort of like in and out, given, statement, reason, statement, reason, statement, reason, we can build the whole flow proof. And it does help to have resources that you can look back on for comparison. That's really one of the key strategies for being successful with proofs. What other examples do you have to look at? Thank you for watching this video. I'm going to go ahead and make a note card or add to my note card the same side interior angles converse theorem, or certainly comment on my same side interior angles. You should do the same thing. I'll see you on page 312 as we continue talking about converses of parallel line theorems. Thank you. Bye.